For your 2.6 part 2 notes, it goes over your nonlinear inequalities and solving them. When we worked with linear inequalities, it was just the x, it wasn't raised to a power. And we got x by itself, and on the left side, and our sign, our inequality sign, told us which way our line went in order to graph it, and then worked from it there. With these inequalities, you're going to have an x to a power, which means you're going to have to test points or use your inequality symbol from the very beginning once all of your terms are on the same side. If you use your inequality sign, you're going to have a greater or less than, greater than or equal to or less than or equal to. If it's greater than or equal to, it's going to be an or statement. If it's less than or equal to, it's going to be an and statement. If you don't use this, you're just going to have to test values. We'll do it both ways so that way you can see whichever one you prefer to do, you use. For the first example that we have x squared is less than or equal to 5x minus 6. For this one, we're going to move the 5x over, we're going to move the 6 over. So we're going to subtract the 5x from both sides. We're also going to add the 6 to both sides. So this is going to give us x squared minus 5x plus 6 is less than or equal to 0. For this one, I'm not going to use what we just said. I'm going to actually test values. So from here, we would factor. Your factors of 6 that added to be -5 are -2 and -3. So this would give us x minus 2 times x minus 3 is less than or equal to 0. From here, you would set them both less than or equal to 0 and then solve them. So with that, x minus 2 is less than or equal to 0, add your 2 over. That gives you x is less than or equal to 2. For your x minus 3 is less than or equal to 0, move your 3 over by adding it to both sides. And we have that x is less than or equal to 3. So on your number line, your 2 is going to be on the left because it is less than the 3, which will be on the right. Both of these are going to have closed circles. If you test values, you're going to test a number less than 2, a number between 2 and 3, and a number greater than 3. Whichever ones give you true statements when you plug them into the original inequality, that's where your shading will go. So if you pick a number less than 2, we can pick 0. We would have 0 squared is less than or equal to 5 times 0 minus 6. That would give you 0 is less than or equal to -6. That is not true. So with this, your shading will not be to the left of that 2. The number between 2 and 3 is 2 1/2, which is 5 over 2. So if we do 5 over 2 squared is less than or equal to 5 times 5 over 2 minus 6. We're going to have 25 over 4 is less than or equal to 25 over 2 minus 12 over 2. So this would just turn into 25 over 4 is less than or equal to 13 over 2. That 13 over 2 is 26 over 2, which is greater than the 25 over 4. So our shading would go in between the two. If we also tested a number greater than 3, which would be 4, we would have 4 squared is less than or equal to 5 times 4 minus 6. That 4 squared is 16, less than or equal to 20 minus 6 is 14. So 16 is less than or equal to 14. That one's not a true statement either. So that shading would not go to the right of that 3. So from here, we just have the shading between the 2 and the 3, with closed circles on both the 2 and the 3. So our interval notation would go from 2 to 3, including both of those. For example B, we have 2x squared minus x is greater than 1. We're going to move our 1 over first, so we're going to subtract it from both sides. This is going to give us 2x squared minus x minus 1 is greater than 0. If we choose not to test values and instead use our inequality symbol, that inequality sign here is greater, or it's going to have two lines that go away from one another when we graph it. So from here, we're just going to factor that 2x squared minus x minus 1. 2 times -1 is -2. Your factors of -2 that add up to be -1 are -2 and +1. So this is going to give us 2x squared minus 2x plus x minus 1 is greater than 0. You have 4 terms, so we'll factor this by grouping. First, we factor out a 2x. Second, we factor out a 1. So that's going to give us 2x times x minus 1 plus 1 times x minus 1 is greater than 0. Your two parentheses are identical, so that's going to give us 2x plus 1 times x minus 1 is greater than 0. We set both of these greater than 0 and we solve them. With the 2x plus 1 is greater than 0, we're going to subtract 1 over. We have 2x is greater than -1. Then we divide each side by the 2 to get that x is greater than -1/2. For the x minus 1 is greater than 0, add your 1 over. You get that x is greater than 1. So on your number line, your -1/2 is going to go to the left since it's less than the 1 on the right. Both of these are going to be open circles since it's just greater than. And we said from the very beginning that it's going to be an or statement, so our lines are going to go opposite directions. So they'll go away from one another. Which means for your interval notation, you're going to go from -infinity to -1/2 with parentheses, with a union from 1 to +infinity with parentheses. For our next example, we have x squared is greater than or equal to 9. For this one, I don't want to take the square root of both sides, so I'm going to move the 9 over and factor it. So I'm just going to subtract it from both sides to give me x squared minus 9 is greater than or equal to 0. It is greater than or equal to 0, so or is going to be what we use when we graph. So this is going to factor to give us x minus 3 times x plus 3 is greater than or equal to 0. This then simplifies to be x minus 3 is greater than or equal to 0, and x plus 3 is greater than or equal to 0. Move your -3 over by adding it to both sides. So that's x is greater than or equal to 3. Move your 3 over by subtracting them from each side. So x is greater than or equal to -3. Again, since this is a nonlinear inequality, we are going to graph those numbers. So -3 is going to be on the left. Your +3 is going to be on the right. Both of these are going to have closed circles because they are also equal to. And then we said in the very beginning that this is greater or our lines are going to go opposite directions. So our interval notation is going to go from -infinity to -3 with a bracket, with a union of bracket 3, infinity. For number 4, you have x squared minus 2x is less than or equal to 0. All of your terms are on the same side here. It's less than and is going to be the way we graph this. You have a greatest common factor between these two terms, so we're going to factor out that greatest common factor, which is x. That's going to leave you with x times x minus 2 is less than or equal to 0. You're separating this to be x is less than or equal to 0, and x minus 2 is less than or equal to 0. Move your 2 over, add it to both sides. That gives you x is less than or equal to 2, as well as x is less than or equal to 0. So on our number line, our 0 is to the left, our 2 is to the right. We're going to have closed circles on both of these since it's also equal to. And we said from the beginning it's less than, and our line is going to connect the two circles. So that means that your interval notation is just going from 0 to 2, including both of the 0 and the 2. For number 5, we have x squared plus 5x plus 6 is greater than 0. Your factors of 6 that add up to be 5 are 2 and 3. This is also a greater inequality, so it's going to be an or statement. So this is going to factor to give you x plus 2 times x plus 3 is greater than 0. We separate this to be x plus 2 is greater than 0, and x plus 3 is greater than 0, and we solve them. We're moving the 2 over by subtracting it, so we have that x is greater than -2. We move the 3 over by subtracting it. We have that x is greater than -3. On your number line, that negative 3 is going to go to the left of negative 2, since it's less than. You are going to have open circles on both of these. We said from the beginning it's greater than, so it's going to be an or statement. Your lines are going to go away from one another. So your interval notation for this is just from negative infinity to negative 3, parentheses, with a union, parentheses, of negative 2, comma, infinity. For number 6, you have x squared is less than x plus 2. We're going to move the x over by subtracting it. We're also going to move the 2 over by subtracting it. So this is going to give us x squared minus x minus 2 is less than 0. All of our terms are on the same side. It's less than 0, so this is going to be an and graph. Our factors of negative 2 that add up to be negative 1 are 1 and negative 2. So this is going to factor to give us x plus 1 times x minus 2 is less than 0. We set that x plus 1 less than 0. We set the x minus 2 less than 0. And then we solve. So we're going to move the 1 over by subtracting it from both sides. We get x is less than negative 1. We move your 2 over by adding it to both sides. We get x is less than 2. So on our number line, the negative 1 is going to go to the left. 2 is going to be on the right. Open circles on both of these. We said from the beginning that it's an and statement since it's less than. So the 2 lines will connect. Your interval notation for this is just going from negative 1 to 2 with brackets on both. For number 7, we have 5x squared plus 3x is greater than or equal to 3x squared plus 2. We're going to move the 3x squared over by subtracting it from both sides. We're also going to move the 2 over by subtracting it from both sides. So this is going to give us 2x squared plus 3x minus 2 is greater than or equal to 0. From here, we need to factor this by multiplying your 2 times negative 2. That gives us negative 4. Your factors of negative 4 that added to be positive 3 are 4 and negative 1. So this is going to get rewritten as 2x squared plus 4x minus x minus 2 is greater than or equal to 0. We're going to factor this by grouping. Factor out a 2x, factor out a negative 1. That's going to give us 2x times x plus 2 minus 1 times x plus 2 is greater than or equal to 0. From here, 2 parentheses are the same, so that's going to give you x plus 2 times 2x minus 1 is greater than or equal to 0. Put your x plus 2 greater than or equal to 0. Make your 2x minus 1 greater than or equal to 0. And then solve them. Move your 2 over, subtracting it from both sides. You get x is greater than or equal to negative 2. Move your 1 over, add it to both sides. You get 2x is greater than or equal to 1. Then divide each side by the 2. So you have that x is greater than or equal to 1/2. On your number line, your negative 2 is going to go to the left of your 1/2. From here, you're going to have closed circles on both of these. We didn't say it in the beginning, but we do have a greater or. So your lines are going to go away from one another. So that just means that your interval notation is going from negative infinity to negative 2 with a bracket, with the union of bracket 1/2, comma, infinity. For your last question, you have x squared plus 2x is greater than 3. We're moving the 3 over by subtracting it from both sides. We get x squared plus 2x minus 3 is greater than 0. This is a greater than, so it's an or. Your factors of negative 3 that add to be 2 are 3 and negative 1. So that's x plus 3 times x minus 1 is greater than 0. This separates to give you x plus 3 is greater than 0 and x minus 1 is greater than 0. So move your 3 over by subtracting it from both sides to give yourself x is greater than negative 3. Move your 1 over by adding it to both sides to give yourself x is greater than 1. On your number line, your negative 3 is going to be on the left, your 1 is going to be on the right. They're both going to get open circles. We said it from from the beginning that it was an or, so your lines go away from one another. So you have from negative infinity to negative 3 with a union from 1 to positive infinity.